Welcome to Mathland. Let's look at question 11. Before calculating anything, let's unify the ratios given in the diagram. We are told the ratio of CG to GA is 3:2. So let's label CG as 3y and GA as 2y. Because GF is parallel to AD, the proportionality theorem tells us that CF to FD is also 3:2. But we are also given that CF to FB is 2:5. To unify these, we find the lowest common multiple of 3 and 2, which is 6. Let CF equal 6m. This forces FD to be 4m and the total FB to be 15m. Subtracting FD leaves us with DB equal to 11m. Now, the whole bottom line speaks the same language. Question 11.1.1. Calculate FD over CF. Isolating triangle ACD, we know GF is parallel to AD. By the line parallel to one side of a triangle theorem, FD over CF equals AG over GC. This is 2y over 3y, giving us 2 over 3. Question 11.1.2. Calculate BA over EA. This time, let's isolate the large triangle, EBF. We are given that AD is parallel to EF. Using the proportionality theorem again, BA over EA equals BD over DF. Looking at our unified m values, that is exactly 11m over 4m, leaving us with 11 over 4. Finally, question 11.1.3. Find the ratio of the area of triangle CGF to the area of quadrilateral GFDA. First, notice that triangle CGF is similar to triangle CAD due to corresponding angles. The ratio of their areas is equal to the square of the ratio of their corresponding sides, CG over the total CA. That's 3y over 5y squared, which equals 9 over 25. If the area of the small triangle is 9k, the area of the large triangle is 25k. Subtracting the small triangle leaves 16k for the quadrilateral. Therefore, the final ratio is 9 over 16.